In this review, we are going to study what we call the nth term test for divergence. So nth term test for divergence. So this only check whether a series is diverge. So it cannot say anything about a series converge. Only test whether a series diverge. Yeah, that's one of the problem with this one. But this is very powerful result. You can save a lot of time remembering this result. Okay, so what the result says, so theorem. So what we call the nth term test. So it says that sigma an gonna diverges if the limit of the nth term not equal to 0. That's it. That's the nth term test for divergence. So if the limit not equal to 0, the series gonna diverge. So, but now the question is how this can happen. So there are two ways this can happen. One way is the limit does not exist. So that's one way. If the limit does not exist, it's not equal to 0. The other one is the limit exists. So you can see that the limit exists, but it is not equal to 0. So the limit exists but not equal to 0. So those are the two ways that this can happen. So let's try to look at some examples. So example number 1 is sigma n going from 1 to infinity 2n over 3n plus 5. So if you look at this problem, you can see that an is equals to 2n over 3n plus 5. So if you take the limit n goes to infinity, an, which is the limit n goes to infinity 2n over 3n plus 5. What you need to worry about is only the dominating terms. So these are the dominating terms. So if you divide those two terms, what you're going to get is 2/3. So the limit is 2/3. Because when n goes to infinity, you can ignore 5. You only need to worry about the dominating term of the numerator and the dominating term of the denominator. So it's 2/3. So which is not equal to 0. So therefore the series diverge by the nth term test. You have to write the argument. So that's the argument. So let's look at one more. So you can see that these problems are like not that long. So sigma n going from 1 to infinity, -1 to the n. Let's say just put some numbers. 3n, 4n minus 2. Okay, like that. So let's say what is an here? An equal -1 to the n 3n over 4n minus 2. So let's take the limit when n goes to infinity. An is the limit n goes to infinity, -1n to the times 3n 4n minus 2. But something else happened here. You can see that in this problem, this part has a specific limit. What's the limit? The limit is 3/4 of that part, right? Because if you ignore -2, is 3n over 4n, that means 3/4. But there's a negative sign that's going to fluctuate. So because of that negative sign, what happened in this problem is the limit does not exist. Because what's going to happen if you look at actually if you just plot those values when for larger n, what's going to happen is going to jump between 3/4 and negative 3/4, 3/4 and negative 3/4. That's what happened on the for large n. So so this is 3/4 and that is negative 3/4. So it's gonna jump between those two values. So that means limit does not exist. So the limit does not exist. That means by the test, so we can say so the sigma n diverge. Okay. So sigma n diverge. So let's look at maybe one more example. So how about this one? Let's say sigma n going from 1 to infinity into the phi half minus 3 sine n squared plus square root n over 5 into the phi half plus 3 n squared plus 7, something like that. Just expression. So what do you do? So this is the n, right? That's n. So what's going to happen? We can take the, again as before, we can take the limit. So the limit n goes to infinity a n. So what you need is, you only need to look at the dominating terms. So this is the dominating term in the numerator, and this is the dominating term in the denominator, and you can see that sine. Yeah, I need to say something about sine. So but we know that the sine is always in between, whatever the function is in between 1 and negative 1. So that means since it is between 1 and negative 1, so it looks like, you know, the absolute value of that term can be maximum 3. So that means, you know, when n goes to infinity, you can ignore that. So that's why we kind of ignore the sine term. So we ignore the sine term, or sine, cosine we can ignore, but you have to be worried about tan. Okay, because tan can go to infinity, but sine, cosine you can ignore for these kind of calculations. Still, it depends how you write it, because if you write 1 minus cosine x, that you have to be careful. Okay, so so what you get is the limit. So we only need to worry about the dominating terms. So we look at the dominating term. So it is n phi half divided by 5 n phi half. So that means they're going to cancel out. So you're going to get 1/5, which is not equal to 0. So then this implies that sigma a n diverges by the nth term test. Nth term test for divergence. Okay, good. Very simple. You can see. How about this one? So we have example sigma n going from 1 to infinity, negative 1 n to 1 over n. So in this problem, what is a n? So you can see a n equal negative 1 to the n 1 over n. But you know that this goes to 0 as n goes to infinity. So that term goes to 0. But what do you know about this series? The series converge. We can show that using the alternating series test. The series converge, but the test doesn't say anything. Okay, so but we cannot say anything. We cannot say anything about the convergence of the series. So this is one of the problems that we have with this. It doesn't say anything about convergence. It only says something about divergence. It's only catch bad people, right? Only catch bad people. Okay, so let's look at one example. So this is like for you to try. So we have sigma n going from 1 to infinity, negative 1 n, n3 minus n cosine 6n divided by 5 plus n squared minus 3n cube. Okay, what can I say about this one? Converge or diverge? Okay, so that's the end of nth term test for divergence.